Okay, Professor Jim Schultz here from my Finance 311 students. I wanted to go ahead and shoot a video here on the expected return and standard deviation homework that you guys have been practicing. And I thought a good problem to go through would be one of these portfolio expected return and standard deviation problems. So let's go ahead and take a look at this first problem from one of the extra sets from the extra set that I sent you guys from essentially chapter 10. So you have a scenario analysis table, and you are given that you have 30% of your portfolio in XYZ and 70% of your portfolio in ABC. Given all this information, what is the expected return and the standard deviation for this portfolio? Okay, so if you remember from class, the first thing you need to try to figure out are these guys right here. So you need to build this synthetic column that represents your portfolio, and you need to essentially figure out how will your portfolio perform in a bad state, in an average state, and in a good state. And here are the answers. But down here, if you focus on this section right here, this is how we arrived at those numbers. So this negative 34.3 was found right here. So if you look at that, that's the portfolio in a bad state, and that is found by taking the return from XYZ in a bad state, which is minus 42%, times the weight of XYZ, which is 30%, so that guy's right there, plus the return of ABC in a bad state, which is minus 31%, so that's right there, found from that number right there. And then you have 70% of your portfolio in ABC, so that is the 70% right there. So that gives you these two numbers, negative 0.126, negative 0.217. So when you net those two together, you get negative 34.3. So that is where this number comes from. And then portfolio average and portfolio good are found the same way by taking XYZ in an average state, 11%, 11%, times the weight of XYZ plus ABC in an average state, 8.5%, 8.5%, times the weight of ABC. And netting those two guys together gives you 9.25%, which is this guy right here, which is found right there. And then finally, the portfolio in the good state is found in exactly the same way. Return of XYZ in a good state times the weight of XYZ plus the return of ABC in a good state times the weight of ABC. So that's 47.9. So then once you have those numbers, to find the expected return of your portfolio, you find it in exactly the same way as you would find the expected return of a single asset, right? So if it's no different than if I were to ask you to find the expected return of XYZ or ABC or Starbucks or McDonald's or whatever. You simply take the probability of that state times the return from that state. So 25% right here times the return in a bad state, minus 0.343 right there, plus the probability of an average state, 55% right there, times the return in an average state, 9.25% right there, plus finally the probability of a good state, 20% right there, times the return from a good state, 47.9% right there. So you work those guys out together, you see it right here, you get 6.09%. So that is how you find the expected return for a portfolio, for any portfolio. Once you have that number, you can then proceed to find the standard deviation for the portfolio. And that is found right here. And basically, I didn't write out the steps because you guys all have the steps in your notes. But I have essentially just followed the 5-step process I outlined in class to solve for the standard deviation of the portfolio. Remember, the first step is to find the deviation from the mean for each state. So that is what you see in parentheses here. The deviation from the mean for a given state will be equal to the return from that state minus the expected return. So for the first state, it's going to be negative 34.3% minus 0.0609. And just like I've done with everything else, I simply put everything in decimal form to make it easy on myself. Once you have that deviation, you square that deviation, and then you multiply by the probability of that state occurring. And so that is essentially where all these numbers are coming from. This is the bad state, this is the average state, this is the good state, right? Again, return minus expected return. return minus expected return, return minus expected return. Square all those deviations, weight them all by the probability, and you come up with essentially a number or a result for each of your states. Then step 4, you simply add those results, and then step 5, you take the square root of the sum. Or I may have misspoke. I may have said you average the results. I'm not sure what I just said 30 seconds ago. But you add the numbers. Do not average. You add the numbers. I was distracted. Sorry, guys. He's looking right at me. He wants my attention. And so he's going to have to hold off for another 30 seconds. But you add the numbers. So if I misspoke, you add these guys together. That gives you 0.07635. This would be your variance for you statistical junkies listening. The square root of that guy is going to be your standard deviation, so that's 27.63. So that wraps up this problem. I hope this was helpful for you guys. This is absolutely something you're going to want to know how to do really well heading into the final celebration.